Hello, welcome back to Blender Sushi LiveNoding. In this episode, we're gonna continue our explorations of Metaballs in SphereChalk. So if you upgrade SphereChalk add-on, you will get the latest Metaballs nodes, and it's gonna look something like this. And the new nodes actually have object output, so that's pretty cool because now we can kind of work with it a little bit more fluently. So let's get started. What we're gonna use today? Maybe plain grid. Okay, just a simple plain grid. So if you have a nodes like plain grid and you are kind of wondering what it does, you can always use a viewer draw and plug the vertices, edges, and you can see you get that, and increase the number of vertices in X and Y, and you get that. It's like a grid polygon. Okay, that's pretty clear. The cool thing, of course, if you plug in the vertices into the origins, which is for the metaballs, and suddenly you have this kind of like a waffle. If you want to make like a quick, I don't know, some kind of cookies that you can use this method. Maybe kind of just flatten it or something. We're gonna save this very quick. So this is gonna be metaballs plain. I'm pretty sure if I ever gonna release my books or like on nodes on SphereChalk and animation nodes, there should be like big topics on metaballs and big topics on grease pencil because they both are my favorite. So you can do a lot of cool things already, just animate this because metaballs will just simply does its jobs, kind of merging, blending, it's very cool. Of course, you can also animate the radius, so you can have that kind of effect. The radius, remember, with the radius you can use random number, and be careful with the value, not too big. Always keep it low, 0 and 1 maybe. And how many points we have here should match the number of random points. So that's I have 10 random points being generated at the moment, but if we increase the value here, and now it should cover all the metaballs. This one, in order to get the exact number of metaballs that we created, it's based on these vertices, right? So we can use list length, and from list length, if you look at this using the stethoscope, you can see total number 24 points, and you plug that in into this size. Now you have the exact number of random points, random radius value based on this random number generator to match the number of metaballs. So everything works. So you can increase the number and everything will procedurally be updated. So that's kind of a cool thing there. If you ever want to turn this into real objects, since we have this object output now, you can actually use the object ID out, and this one comes in handy. And of course, this is gonna turn it into a mesh, and you need to use a bmesh, viewer bmesh, and then just output it like so. Post modifier maybe on, and this guy doesn't seems to be updating properly. Let's check it out. Yeah, that's interesting. Maybe these nodes need to be updated so that it works with our metaball. But basically, we can use objects in or objects in. Let's see, object out. Okay, so we actually already have some objects there. If we plug that in, we should have a mesh object. Matrix in. Let's try put this to the side. So that's the mesh objects. Okay, that's interesting, but supposedly if you use the object ID out, this should generate vertices here that we can, and we can output our mesh. Well, I guess don't worry about that. For now, we're just gonna play with our Metaballs. So go back to object mode and refresh everything. So we have our Metaballs, and for the planes, let's make it, let's turn it into some kind of wave animation. There's always like a classic example. How do we turn like all these points of a plane into a wave? That's kind of like difficult question, sounds like, but it's not really, because if we just break the vector points of the plane into x, y, z, you can see the points in the x and y plane. Those are the value that's kind of growing, so you can make a wave either based on the x or based on the y. And at some point we're gonna combine the points back. So that's the idea. So for the x, let's play with the math here. So we have all this x value that's kind of growing, and we're gonna back and plug this in, and we also need a value for the y. So let's see if this is working. If we kind of use math and kind of push the value, so that's kind of giving us that. So what's wrong with it? Okay, I just used the x to kind of make this kind of animation, like but what we actually want, keep the x and y, but use the x value, x and sine value into the z-axis. So that's that should create a wave. So x and y goes in there, but the z now being controlled by the value of x that goes into the sine. So now we can have nice wave. And this is not really only kind of like super basic stuff, but still kind of interesting. And remember, you can always use a multiply and all that. Multiplier here. That's gonna make a bigger wave or kind of smoother kind of wave. You can actually plug a frame number there. Let's let it animating. That's too fast, of course. You can always multiply the value. That's okay. That's a pretty smooth wave. It's pretty cool. At this point, you can always add like a vector noise or things like that as well. So vector noise. This is just a quick example, very basics. And vector math here. You can actually do the noise in the Z only, but we're gonna do it this way anyway. It's gonna randomize it in the XYZ now. So now we get that. It's pretty random, but you see, when I actually hide everything, hide the nodes, it's gonna be like a lot faster. It's kind of really nice animation there. Actually quite like it. We can go further and further with this, but if you actually don't want to deal with all this kind of nodes, and if you're like prefer to work, for example, you use a, let's say you are using a torus. This is like a real objects, normal objects in Blender, and if you use like a modifier like ocean, ocean modifier, I think just turn it into ocean. No, maybe use like a deform displace modifier, and then you use a procedural texture like cloud, and you're gonna animate it using maybe using empty. So empty, and then you can animate that, right? that's something that's easier to understand. If you actually want to use this, it's actually pretty easy. You can simply source it into SphereChalk. So I'm gonna keep this one. This one is like a wave in SphereChalk using grid and sign. Make another node tree and objects in. Get selection, this torus. Turn on post modifier, and let's see, use a viewer draw first and check how many vertices we have. Okay, so we have that vertices like that, but it's back in the normal position, even though the modifier is actually working. Use apply, matrix apply, just apply the transformations to the points, and now we can actually use Metaballs here. So this is why I really like kind of like a procedural Metaballs. It's give you a lot of easy way to quickly test something and turn it into Metaballs very quickly. You can think of it like instancing, particle instancing, or dupli in Blender, dupli vert and things like that, but just you can do a lot more. So this is donut Metaballs. And if you want to make this animating, of course, what should we do now? You can animate this locator. To animate the locator, I actually like to use animation nodes, but we can use SphereChalk as well. So object set, object ID set, or let me check, object ID set. So just grab our empty, and then for the delta locations we can randomize it. We don't have wiggle in SphereChalk, but you can make yourself, maybe using frame vector out, actually vector noise is expecting vertices, so vector in, this goes into that guy, this goes into that guy, output a scalar, oops, actually vector. That should control our empty. Maybe a little bit fast. Multiply this by 0. If you want this more like real time at the moment. If I'm not wrong, the instancing in animation nodes is actually very fast. So you can use that with Metaballs, and you get probably more interactive animations. With SphereChalk, it's actually not a problem at all, because when the things get more complex, you definitely want to bake it as Alembic anyway. So in the next video, I probably talk about how you can bake this as Alembic, or something like a stop motion animation that you can export and upload to Sketchfab. So that's gonna be interesting. So let's keep this donut and wavy plane for now. I think this is quite a lot of information already. You can give it a try. So anything like any point generators or any point manipulations inside SphereChalk, you can easily turn into Metaballs thanks to this Metaballs nodes. Still in a beta, but this is already pretty powerful. The object should work, but maybe it needs to be, maybe there's a slight bugs. I'll check it with a SphereChalk developer, but that's pretty much it for this live noding. Hopefully you enjoy this. I'll see you next time. Bye.